Hey guys, so last time we looked at how to add, subtract, and perform scalar multiplication on matrices, and today we're going to look at how we can multiply matrices, which is a little bit different from adding, subtracting, and scalar multiplication. So we're not going to multiply corresponding entries anymore. And so multiplying matrices is a little bit trickier, and it requires us to look at the dimensions of the matrix to see if it's even possible to multiply them. So if we look at two matrices, H and G, so in this case, if we look at the dimensions, it looks like H, matrix A, H is a 2 by 2 matrix. Remember, the dimensions are row by column, so we've got 2 rows, 2 columns. And we always write row by column. And then matrix G is another 2 by 2 matrix. Now, in order for us to be able to multiply them, the rule is that the column of the first matrix must be equal to the number of rows in the second matrix. So the number of columns in the first matrix is 2, must be equal to the number of rows in our second matrix, which is also 2. And so in this case, we can multiply these so that basically the two inner numbers have to be the same. So have to be equal. To multiply. The number of columns in the first matrix must match the number of rows in the second matrix. Okay, and then once we determine that it's possible to even multiply the two matrices, then the dimensions of the resulting matrix after we multiply them is given by these right here. Okay, so 2 by 2, I know that my resulting matrix is going to be 2 rows by 2 columns, so I'm going to write that over here. This gives the dimensions of your resulting matrix after you multiply. So I know that after I multiply H times G, my resulting matrix is going to be another 2 by 2 matrix. Why does the number of columns have to match the number of rows in the second matrix? We're going to see, because matrix multiplication, we do not multiply the corresponding elements. We multiply row by column. And here's how we do it. So let's look at how we can multiply H times G. So we look at H, that would be the 2 by 2 matrix with the first row 1, 3, negative 4, 2, times G, which is negative 4, negative 2, 1, 1, row by column. And so when we multiply this, remember what we said about the dimensions, 2 by 2 times 2 by 2, inner numbers tells me yes, I can multiply them, and the outer numbers tells me the dimension of my new matrix. So I know that my new matrix after I multiply is going to be another 2 by 2. I'm going to space out a little bit so I can show you the work of how you calculate it. Okay, so I know it's going to be a 2 by 2. I'm going to have 2 rows and 2 columns. Okay, and how we figure out the rows and columns. What is my first entry over here? Well, remember the location of your first entry. So the first entry that we're trying to figure out is in the first row, first column. So in order to get this element or entry, we have to multiply the first row by the first column. So we're going to put the first row, we have negative 1 times negative 4, multiplying the first row by the first column, 1 times negative 4 plus 3 times 1. Okay, so the first entry multiplied by the first entry, or the elements, plus the second entry multiplied by the second entry. So after you do out that calculation, that gives you your first element in the first row, first column. So that's going to be negative 4 times 1 is negative 4 plus 3. That's going to give me negative 1. Okay, moving on to the first row, second column. In order to figure out what this element is, we are going to multiply the first row by the second column, because that's the location of this element that we're trying to figure out. The location of this element is at the second row, the first row, second column. So we're going to have to multiply the first row by the second column. So that's going to be 1 times negative 2 plus 3 times 1. Okay, simplifying that, that's negative 2 plus 3, that's going to give me 1. And then moving on to the next element that we want to find, the location of this element is in the second row, first column. So in order to get this, we have to multiply the second row by the first column. So that will be negative 4 times negative 4 plus 2 times 1. Simplifying that, that's going to be 16 plus 2 is going to give us 18. And then last element, the location of that is in the second row, second column. So in order to get that, we're going to multiply the second row by the second column. So that's negative 4 times negative 2 plus 2 times 1. Keep this highlighted. Negative 4 times negative 2 plus 2 times 1. So that's going to give me 8 plus 2 is 10. And here is my new matrix after I've multiplied them. Another 2 by 2 matrix with elements negative 1, 1, and 18, 10. So let's try that for GH. Now I know that in regular multiplication of real numbers, 3 times 2 is equal to 2 times 3, right? Multiplication is commutative in our real number system. Let's see if that's true under matrices. Let's see if matrix multiplication is commutative. So we're gonna swap it around. I'm going to put G on the left, negative 4, negative 2, 1, 1, and I'm going to put H on the right, 1, 3, negative 4, 2. Now this part you do not have to show every time. If it helps you, go ahead and show it. If you don't need it, you don't need to show that. Alright, I'm just writing it out the first time for you so you can have it in your notes of how to do it in case you forget. So let's take a look at this one, GH. 2 by 2 times a 2 by 2. So I know that my resulting matrix is also going to be a 2 by 2. So 2 rows, 2 columns, and I have to fill in all the elements. So let's start with the first one. My first element, the location is in the first row, first column. So in order to get that, I have to multiply the first row by the first column. So that would be negative 4 times 1 plus negative 2 times negative 4. So that would give me negative 4 plus 8, which will give me positive 4. Okay, moving on to the next element is in the first row, second column, always row by column. First row, second column. So we're going to multiply the first row by the second column. Negative 4 times 3, that's negative 12. Negative 2 times 2, that's negative 4. Negative 12 plus negative 4 is negative 16. So negative 16. Okay, and then moving on to the second row. Next entry is in the second row, first column. So we're going to multiply the second row by the first column. 1 times 1 is 1. 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. So negative 3. And then last entry is in the second row, second column. So we're going to multiply the second row by the second column. 1 times 3 is 3, plus 2 is 5. Okay, and here is your matrix. So if we take a look at HG versus GH, my resulting matrices are not the same. And so therefore, we can conclude, and it's important to know, that matrix multiplication, so as a note, matrix multiplication is not commutative. So it does matter which one you multiply on the left and on the right. H times G is not the same as G times H. So let's take a look at example 1. In example 1, we have R, which is a 3 by 2 matrix, 3 rows, 2 columns, and a 2 by 2 matrix W, 2 rows, 2 columns. And we want to find RW, so R times W, and W times R if it exists. So go ahead and let's write this out. Let's start with RW. So negative 4, negative 6, 5, 4, negative 6, negative 1, times 4, 6, 0, negative 3. And let's look at the dimensions to make sure that we can even multiply them. I have a 3 by 2 times a 2 by 2. Okay, looks like the inner numbers are the same. The number of columns in the first matrix matches the number of rows in the second matrix. So this tells me, yes, I can multiply them. And I know that after I multiply, my resulting matrix is going to be a 3 by 2 matrix. So I would draw that out first so I know how many entries I'm going to have, or how many elements. I have 2 columns and 3 rows, 6 total elements. Okay, so now go ahead and pause the video and see if you can multiply and figure out what your resulting matrix is going to look like. And then do that for WR as well. And then once you're done, you can skip ahead in the video and see if you got it correct. And if you didn't, you go back and you rewatch. So first element, we're going to look at first row, first column, and we're going to multiply the first row by the first column. Negative 4 times 4, negative 16. Negative 6 times 0, 0. So it's just negative 16. First row, second column. Next entry. First row, second column. So that's negative 4 times 6 is negative 24. 6 times 3 is positive 18. Okay, negative 24 plus 18 is going to give you -6. Okay, moving on to the next row. My next element is in the second row, first column. Second row, first column. And as you're doing this, it might be helpful, especially when the matrices are big, it might be helpful to use your fingers to cover up the rows and columns that you are not using so that you don't get confused. So 5 times 4 is 20, plus 0 is still 20. Okay, next element, second row, second column. So that would be 5 times 6, which is 30. 4 times -3 is 12. 30 minus 12 is going to give me 18. Moving on to the last row. Next element is in the third row, first column. So third row, first column. -6 times 4, -24, plus 0 is still -24. -1 times 0 is 0. Okay, finally, last element in the third row, second column. So third row, second column, -6 times 6, -36. -1 times -3, +3. -36 plus 3 is -33. And that is your matrix RW. Now let's do the reverse and look at WR. So swapping those, we have 4, 6, 0, -3 times -4, -6, 5, 4, -6, -1. And again, let's compare the dimensions. I have a 2 by 2 and a 3 by 2. Okay, we have a little problem because if we look at the inner numbers, the number of rows, the number of columns in the first matrix does not match the number of rows in the second matrix. So because these two numbers are not the same, we cannot multiply. And so this product, W times R, we're going to say that it does not exist. DNE does not exist. Okay, or you could also say that it is undefined. So just because we can multiply R times W does not mean we can always multiply W times R. Alright, let's take a look at an application problem of where we can use matrix multiplication to help us solve problems. Alright, so example 2, nutrition. We've got Grady and Max who are making 2 snack mixes by mixing dried fruit and nuts. The amount of protein, carbs, and fat in grams per serving for the dry fruit and nuts are given in table 1. So we know that dry fruit has, for every serving of dry fruit, there's 3 grams of protein, 65 grams of carbs, and 1 gram of fat. And then for each serving of nuts, we have 20 grams of protein, 21 grams of carbs, and 52 grams of fat. So nuts are very fat. And then for table 2, we've got the number of servings of dried fruit and nuts in each mix is given in table 2. So we're gonna make 2 types of mixtures. We're gonna mix a sports mix and a camp mix. And we're going to put in different amounts. So the sports mix is going to contain 4 servings of dry fruit and 2 servings of nuts, and the camp mix is going to consist of 3 servings of each. So the first thing I want you to do is to represent the information from table 1 in a matrix called N, and represent the information from table 2 in a matrix called G. So this is very similar to what we did in the last lesson, where you have to represent the number of studying hours for math and science before midterm and before final as a matrix. So when I say matrix N can be written as a 3 by 2 matrix, 3, 20, 6521, and 152, where the columns represent the dry fruit and nuts, and the rows represent protein, carbs, and fat. And then we can represent the second table as a matrix G, and we can use a 2 by 2 matrix for 3, 2, 3. And in this case, the columns represents the sports mix and the camp mix, and the rows represents the amount of dry fruit and nuts. Okay, so just like what we did in the last lesson, representing the information, instead of using a table, we're going to use a matrix. And in part B, we're going to do something with that to help us answer questions. Okay, so now we're going to multiply and find the product NG, and that's going to help us determine which mix has more proteins and which mix has less fat. So let's go ahead and look at the dimensions to make sure that we could even multiply them, right? So the top half of this is just the slide from the previous page because I wanted to look at A and B together as we're doing them. Here is NG. N is my 3 by 2 matrix. And G is my 2 by 2 matrix. And you can use a calculator to help you multiply. So we've got 3 by 2 times a 2 by 2. The number of columns in the first matrix matches the number of rows in the second matrix. That means yes, I can multiply them. And I know that after I multiply, my resulting matrix is going to be a 3 by 2. So it's going to have 3 columns and 2 rows. All right, so go ahead and pause again, multiply them, and then I want you to think about, after you multiply your new matrix, what does the rows and the columns of this new matrix represent? So, multiplying, I have the first element, first row, first column. That's 3 times 4 is 12. 20 times 2 is 40. 12 plus 40 is 52. Okay, second element, first row, second column. That's 3 times 3 is 9. 3 times 20 is 60. 69. Okay, and then your numbers get a little bigger. Moving on to the next row. Second row, first column. Second row, first column. 65 times 4 plus 21 times 2. And you should end up with 302. And then next element, second row, second column. Second row, second column. 65 times 3 plus 21 times 3. You should have 258. Last row. Start with the element in the first column. So third row, first column. Third row, first column. Remember, you're always multiplying row by column. So that's 1 times 4 plus 52 times 2 is going to give me 108. And then last element in the third row, second column. So multiply the third row by the second column. 1 times 3 plus 52 times 3 should give you 159. Okay, so now we've got the multiplication part down, and the hard part is interpreting the problem, using the math to help us solve the situation. Think about what the rows and columns represent And think about where the rows and the columns came from in this new 3 by 2 matrix. Remember that 3. These 3 columns in my new matrix came from the 3 rows in my new matrix came from the 3 rows of my first matrix, N, right? So we really took the rows from N, and so my rows represent protein, carbs, and fat. And then the 2 columns in our new matrix came from the 2 columns of matrix G. And so we took the columns of matrix G, and our new columns represents the sports mix and the camp mix. And by multiplying them, by multiplying N and G, I came up with a new set of data. I came up with a new table, a new group of information that now compares the amount of protein, carbs, and fat in each type of mix, sports mix and camp mix. And then we can answer the question. So it says, which mix has more protein? We look at protein, it looks like camp mix has more protein. Okay, so camp mix has more protein. And which mix has less fat? More protein, less fat. It looks like sports mix has less fat. All right. So using matrices to organize and figure out new information to help us solve these types of problems. Well, let's look at one last example. Let's use what we know about matrix multiplication to solve for x and y. So we have a 2 by 2 matrix, two rows, 2 columns, times a 2 by 1 matrix, 2 rows, 1 column. Okay, inner numbers are the same, so we can multiply them. And I know that after I multiply, I'm going to get a 2 by 1 matrix, which is right here. This is the 2 by 1 matrix that I get. So in order to solve for x, let's see if we can do the process of multiplying. Now, if I were to multiply these to get the negative 18, let's go the reverse and think about how I got this 19, this negative 18. This negative 18 is in the first row, first column. So in order to get the negative 18, I had to multiply the first row by the first column. And so my first equation that I can come up with is, in order to get the negative 18, I had to multiply 1 times x plus negative 3. So 1 times x plus negative 3 times y. That gives me negative 18. Okay, and then how about the negative 1? In order to get the negative 1, which is in the second row, first column, I had to multiply the second row by the first column. So that would be 2 times x plus 1 times y in order to get this negative 1. And so we have 2 equations, and guess what they look like? X minus 3y equals negative 18, and 2x plus y equals negative 1, and I bet you know how to solve for x and y. Let's do substitution elimination. Okay, so in this case, I'm going to do elimination and multiply the second equation by 3 to make opposites. And I'm going to rewrite this. So x minus 3y equals negative 18. Second equation becomes 6x plus 3y equals negative 3. and we're going to go ahead and add. My opposites cancel out. I have 7x equals negative 21, and so x equals negative 3. And then I'm going to plug it back into the second equation. 2 times x, which is negative 3, plus y equals negative 1. Negative 6 plus y equals negative 1. Add 6 to both sides. Y equals 5. And so we have x equals negative 3 and y equals 5. That's what x and y is. In this particular case, you don't have to write your answer as an ordered pair because technically I'm not asking you where do the two lines intersect at a point. I'm just asking you to find x and y in this matrix. And to find that, you use the method of substitution elimination. It's just a process that we're trying to use. Okay, so x equals negative 3 and y equals 5. Your homework is going to be the next 2 pages that's attached. So it's going to be practice on what we learned in the last video on adding, subtracting, and scalar multiplication, and then adding on multiplying matrices. So that's going to be your homework. For the rest of class, you guys can either work together on the homework, or if you want to get into your groups and work on your linear programming project, that's okay as well. Have a nice weekend.